Okay, so hello everyone. Welcome back to Intro to Backend Development. Today we're going to be talking about authentication, and yeah, let's get started. So for some announcements, PA6 is going to be due this Wednesday. So I think that's going to be, let me check. It's going to be November 29. So after Thanksgiving break. And this is going to be the last assignment for the semester, and it doesn't involve very much coding at all. And Hack Challenge is going to end December 2nd, and that's going to be um, next Saturday. So now let's go back into some review. So HTTP communication. So we send HTTP requests between clients and servers, and clients send requests that contain like a URL, query parameters, method, and body. So you think like a post request sending um, a transaction body info, or like when you want to get a specific user, you put the user ID in the query parameter and the URL to like get user one. And the server sends responses back to the client that contains a body, which can be like the created transaction of fields, and also a status code like 200, 201. So 200 if it's okay, 201 if it's created something, or it could have error codes like 404 if it couldn't find a resource, 400 if it's forbidden, I think, and so on. So in our like application, we would want to incorporate users such as like their settings. We want to have a user's settings. We want to be able to tell if their content belongs to them or if the social features is for them. And we want to incorporate these features with making sure that the person using our app right now is that user so that they're allowed to, say, access these resources or manipulate them. Like changing a user's settings, we need to know that they're that correct user first. So to do this, we need to identify people who are making our requests as the users that they say they are. So how do we actually do that? Here is a pretty bad example. Imagine we have a social media website where you can make posts and you can just put in the title, link, and user. This is probably, I think this is almost exactly like PA1's format where you can have make Reddit posts with the title and link, and your user would be the user field in this JSON. And anyone can make any user field. So there's no way to know if you're actually Rahi in this case. So that's where authentication comes in. And authentication is just a way we can determine if a user's identity is who they actually are. And we do this by including additional information in their requests. The server will validate these requests based on the additional information, like their username and password credentials. And we can create specific permissions based on the user's identity. So here's a typical flow of user registration and login. So if you're trying to log in into like, or you're trying to make an account for Instagram or something, you need to put in your email and password and then create an account. So by doing that, your credentials are actually sent to a database where the database will encrypt them and store them. Well, it'll hash them so that if someone to actually get access to your database, they won't be able to just read the passwords that are stored in there. And so if you want to log in this case, you type in your email and password, it'll be sent to the database server, and then our backend will authenticate the password and username and see if it already exists in the database. And if it does, then they can just log into that account. So the way that we actually send this data is not through like the body of a JSON like normal. We actually use something called HTTP request headers, which contains metadata about the request. Some examples are like the content type, which tells your browser and any other server reading the requests what kind of body this request is informed. So In our class, we've been using our content type as JSON since we're sending JSON bodies. We can also have the cookie header, which has user state information. And you guys probably seen this when you like go to a website and it asks you to enable cookies so that they can store information about you. We have the user agent header, which actually contains data about your browser and other data about your hardware, like a Mac or Windows. And then we have the authorization header, which is where we will be passing our credentials. And here's what the headers look like. I think this is probably for Chrome. Let me see. The user agent's not on here, but you can see like the content type is something called an octet stream. Not sure what that is. The method is post. We're using HTTPS as our scheme. And yeah, it's a bunch of things that servers or like Postman or whatever will use to automatically glean information about a request. So yeah, and you can see the cookie header has a lot of other information that websites will typically use to store data that they might need. And it can be a lot of like tracking data as well. And so for the authentication field in the header, there are three big ways that you can do authentication on a backend. The first one is HTTP basic, which is going to go on first. The next two are HTTP session and HTTP token. So starting off with HTTP basic, as a name might tell you, it is the most basic of the three. And in this one, you just encode your username and password via like base64 encoding. And you cache or store the encoded credentials on your front end. This could be like a browser or iOS, Android app. And whenever you want to make a request to the server, like updating some field in your user, like your username or something, you'd send these encoded credentials to the server via the header, authorization header, and then the server will validate these encoded credentials. Here is an example where we're making a GET request to my files via HTTP. We're sending this to google.com, and the authorization header has the word basic. And then after that is a bunch of random letters and two equal signs. Two equal signs show that it's a base64 encoding. And you can like look up online base64 encoders where you can put in text and it'll spit out a base64 encoded string. And this one just happens to be the encoding of the username plus the password. And you can just decode this as easily as you can encode it. So it's not like encryption where it's hard to decrypt. It's very easy to encode or decode base64. So if you were trying to register like a user, you would send your username and password via like a registration form to your server. The server would create that new user and then return like the user body or like all the fields in the user, like we've done in like previous assignments, back to the client, as well as with like the success code so that we know it works. So if you wanted to log in or use specific privilege requests, you'd send your encoded credentials via the header like we said earlier. And the server would decode these credentials via like a base64 decoder. And it would validate the password with the password we have in the database. And then it would return a response. So if it was successful, we would send back the data of that request that we wanted to use. And if it didn't work, we'd send like a failure response. So HTTP basic does have a few benefits. For one, it's very simple. It's makes it easily accessible to many technologies. There's no real hurdle with using this kind of system. Users don't have to like rely on a specific front end for using this, since you're just sending your username and password in like base64. And any client can basically use this service as long as they can just send their username and password. But there are some pretty heavy drawbacks. Since you're sending your username and password in base64 with your requests, if anyone's like listening to the packets you're sending to the server, via like I guess Wireshark or some other man in the middle attack, then they can just decode your header, your authorization header, and then just read your password out. And since these username and password is stored in the front end, if you were to like close the web page, it would most likely clear the cache and then you'd have to relog in. Although most of the time cache is stored for multiple instances of a web page. And for the first point where people can read your request, it's heavily dependent on whether or not you're using HTTPS, which is called like secure HTTP, which encrypts the requests that are being sent from client to server and so on. So then in that case, they wouldn't be able to read your authorization header if they were sniffing your packets. But it's very dependent on whether or not the website you're using is using HTTPS. So it's just not really secure in general. Next, we're going to go into HTTP sessions. Ooh. So this is different in the way that we actually store the session of the user and not their email or and password. So it starts out the same with sending their username and password to the server, and then the server validating the credentials, just like logging in. And then after that, the server will actually generate a session that has a cookie associated with it. And then the front end will store that cookie. And whenever you want to make a request that requires you to be logged in, like updating the user name of your user, you just send that cookie instead of your actual username and password. So like before, here's the cookie header and typical header. There's a bunch of fields like key value pairs where it's like ES2 equals that stuff, ET equals a bunch more stuff, locale equals EN. So cookies is like a list of key value pairs, and we can just add our own that has your authorization. And you can see there, that's where we store our session. It's like sessid colon, and then a bunch of letters and numbers, which are like the actual session thing that we're going to check on the backend. And then after that, you can see EXP session, which is where it expires. So if you're registering a new user, you send your username and password to the server. The server will create that user, create a new session, and then return the cookie. So you start out logged in. And then you want to store that cookie on your front end or browser. So if you want to ever make a privileged request, you just also send the cookie in your header to the server. And then the server would parse this cookie as session code. It'll validate if it's a valid cookie, and then it will just return the response as if you're logged in. However, the cookies can expire, which is really good because imagine if someone got your cookie, you wouldn't want to have access to your account forever. So it'll expire pretty quickly. It depends on what you want it to be. And if it expires, then we return a failure response saying that the cookie's expired. You're going to have to relog in. So upon relogging in, it validates your credentials, your password, creates a new session, then returns a new cookie. So the important thing is that the old cookie from before is never going to be used again for your new cookie. So if someone has your old cookie by like going onto your browser and looking at your inspect element and looking at like, well, using JavaScript to like print out your cookie or something, or sniffing your packets, they won't be able to use that cookie anymore because you have a new one that's not expired. And this is kind of the general flow. So you'll get your new cookie back and it'll be refreshed in that kind of way. So it'll expire later on. So some benefits, you won't have to continually send over your password whenever you're making a request that requires logging in, since you can just send your cookie instead. And you can tune the expiration time to be what you want it to be. If you want it to be more convenient for users, you can just make it longer. But if you want it to be more secure, you can make it really short so that they have to log in a lot, which is kind of annoying, but it's for security. So for some drawbacks, you're saving this cookie in like your memory, your browser memory. So if you were to ever like delete your cookies from your browser when you're like deleting your history or whatever, then you're gonna have to log in again. But that's not too bad of a drawback. Oops. Oh. Last but not least, we're going to talk about HTTP tokens. And this kind of is the best of all the worlds. So, like before, we log in with our username and password, we get our credential, and it validates our credentials. But this time, the server will generate and return a unique access token, which is kind of like a cookie, wherein the front end will store this token, and then the client, will always send a token to every request to show that you're logged in. So here it's a bit different. Use the authorization header for this one. So if you have a GET request for my file like google.com, in your authorization header, you're going to have bearer. And then after that, you'll have a bunch of letters and numbers that comprises your access token, as you can see right there. The access token is stored in a database so that it's related to the user ID that is connected to that token. So if you try to log in or if you try to authenticate into a request with token, the server can know what user that token belongs to. But since we're storing this in the database, we don't want this to last forever. So we really want this to expire as well. So after these tokens expire, maybe start from the beginning. So since we store these in database, we don't want someone to be able to like catch them and then have access to your account forever. So we want to design this to be able to expire after a period of time so that accidental exposure of your token has no permanent or lasting effects. And when it expires, unlike cookies where you have to like re-log in, we have something called a refresh token that allows you to make a new access token without having to log in. So that's like an enhancement on cookies. And this is like a one-time use token to refresh your access token and give it a reset expiration time. And one nuance about the refresh token, when you use it to refresh your access token, it randomizes your access token and then refresh token so that if someone has the old ones, it won't be usable. So the text will like be randomized again. And I'll show you that in a bit. So here's like the tokens table. This is probably what you guys are going to want to use if you use authentication for Hack Challenge. You're going to want to have the user ID referencing like the user in question, and then the access token that will log them in, will authenticate them for any requests. Each access token will have to expire at some time. Here it's an integer, so it could be like a Unix timestamp, but you can also probably use a different like timestamp field. Not too familiar. And then you also have the refresh token, which is another text field. So general flow, if you want to make a new account, you send your username and password or the registration form. And the server will make a new user. It'll create 2 new tokens, one refresh, one access token, and it'll return them back to the client. This is just almost like cookies, where you make a new cookie and you send it back. No new thing here. And so if you want to make a request, you have your access token, you send it with your request body in your header, your authorization header, and then the server will validate the token, then execute the operation that you want to do. Like I want to make a post with my Instagram account. I need to be logged into that account, so it'll validate that to me. Then it'll make the post, and then it's going to return some response. However, if my token is like incorrect or expired, then it'll return like an error response. In this case, my token was expired, so I can't actually post anything or do anything with this request. So if I have an expired access token, the neat thing I can do is actually send in my refresh token on like a separate endpoint, like refresh like a post endpoint called refresh or something. And with this refresh token, the server will validate that this is the one in the database for me. And then it is going to create two new tokens, one new refresh token, one new access token with updated expiration times, and then send those back to the client. And that keeps your tokens fresh. And so if someone had your old tokens that were expired and you refresh to get a new one, they won't be able to use the old one still because you have a new, brand new token with brand new expiration time, and you don't have to log in again for this. So no login required. And so some benefits: you send your password through HTTPS less frequency because less frequently because you're using refresh tokens instead of sending your password. And like cookies, you can tune your expiration time to be more convenient for users or for security. And since we're using databases to store these tokens, it tends to be more scalable than just cookies. And yeah, that's three authentication schemes. I I suggest that you guys use HTTP tokens for the hack challenge if you guys are using logging in and authentication in your projects. And yeah, thank you for watching.